process monitor. Process monitor has certain options that you can say, if it's a service, for instance, on Windows, you can actually specify in the process monitor option, say, to restart the service, do net stop this, net start this. It'll restart the service rather than using the VM control. So it's really your preference, but the cleanest way to do it is the VM control if you have that option.
All right, let me just switch it over to my trend demo, which hopefully will be a little bit smoother. Can you switch these drives while I go over this stuff? So the trend demo is a little bit, it's a better example because it's a little bit more complex, so you can kind of see some of the better features of the fuzzer. So because it's a DC RPC, it's a RPC endpoint. So I mean, you can see in this driver script, I kind of defined it a little bit more. Because it's freeform, I had two options. I made it so I can send a single request, or it would be the full fuzz. And in this case, we have it's only single deep, so the root node is going to connect to these, 6 different requests that I have set up. This stuff all looks familiar. And then here is the RPC bind presend that I have defined. And so this utils.dcrpc.bind is from Sully. And all it's doing is saying, okay, set up the RPC interface, because then the data is going to be coming afterwards. You got to change the driver. Yep.
Change driver paths. Yep.
1 second.
Enter. Yes.
And so here's the actual request. So I'm setting up in this case, I'm using this is the benefit of having it in Python. I'm generating 6 different requests, but I'm doing it programmatically. So I'm saying for every operation number and submax. So the way that the trend protocol works is that you've got an opcode, and then each opcode has a certain number of subcodes. So I reverse that out, and I put it in here. So opcode 1 has 22 subcodes, 2 has 19, 3 has 85, etc. So for every one of those, initialize a new request where the name is the target port and then op-op number. Then create this new block, which the encoder is an RPC request encoder. Again, it's built into Sully, so you don't have to worry about defining all the RPC types. You just worry about string, data, whatever. And then here comes the request number. You can see here I'm using Python's map functionality to automatically generate this group. Arrow would love that line of code, my map car here. And some standard things. There's a string, a sizer, the block ends, all this jazz. So
we have simpler examples. If you want to get going and you just download this, there's an entire request library that we have right now that has basic stuff like HTTP and a few others if you just want to get a feel for it, rather than having to do all the crazy encoding and stuff like that, which is a little daunting at first.
Here's the VM control. And I've already done this whole snapshot thing where there's a snapshot of the netmon and the procmon running. So I'll just say, fuzz trend. And this should come up with a nice clean session. So here's the virtual machine control. It got the request from the fuzzer saying, okay, it's time to bring up the virtual machine. And one of the nuances of the VM run command is that you can't intermix manual VMware with automated VMware. So if you started VMware, VM control can't play with it. You have to stop VMware and let the VM control deal with it on its own.
Which is why my demo kind of froze for a second there. Because what I would have had to have done after setting that snapshot is just close VMware and then let the VM control itself start it up, which is what this is doing right now.
So it's restoring the virtual machine state, and then it's going to start fuzzing. And when it does, we should have a nice new fresh web interface. So this is coming up. You can see the procmon and the netmon. They're getting invoked. Now it's saying, hey, start testing. And I skipped it forward to 36 because I know that there's a fault at 42, just so you can kind of see it happen in real life, and it better happen. Here, there it is. You can see it already caught it. It's restarting the virtual machine. It was a 40, not 42. So it caused a fault. Obviously, this is exploitable. And it's got everything saved, and now it's going to restart the virtual machine to a known good state and then keep running. And so this restarting is actually really important. We were fuzzing Veritas something or other. And what had happened is originally I was just using the process control to just stop and to restart the service, because it's obviously a lot faster than VM control restarting. But the problem I was hitting is that one of my fuzz cases was setting some registry option that was actually causing the fault. So it was an infinite CPU usage in Veritas because of some registry key that my fuzzer was able to create. So even if I stopped and started the entire OS, it was still going to default to a full CPU lock. So this is the benefit of having a VM controls, that you can go all the way back and make sure that you have a known good state. And you can see this thing is just working completely unattended. We can just sit here, and it's actually really fun to watch. Like, you just let it go, run, and it's doing all the work for you. If I wanted to, I could pause it, resume it, all that jazz. Are there any questions thus so far? Yes, no? Before I jump into the future stuff.
On your random type,
Mm-hmm.
can you kind of inject value to it on the replay? So if you've got a first case where you've gone through, you've found the version you want to either instrument it more, or I need to change the code if you're still working on that, can you then replay your first with the same values that were previously used as random?
So the question was, we're generating all this data, right? And it's deterministic. So if I have strings, integers, etc., if I run through the whole fuzz session and I run through it again, because the data is generated on the fly and it's deterministic, it's going to be the same. But the question is, well, how do you deal with that with random data? Because it's random every time, what if you want to replay one? Well, that's where the PCAPs come in handy. Because if I saw that a certain test case caused the fault, I can go pull up the PCAP, I can look at what that actual value was, and then swap it from random to static to replay it. So that's how that is handled.
And not only that, you could rip it out, and instead of a random, you could change that to a string and add that actual value to the string fuzz library. So it would be another magic value they might want to work with.
So we have just a couple minutes left. Let me quickly go through some of our future stuff. So these are things that are nearly done. And when I say nearly done, I mean they're finished but just not ready to kind of give to you guys. The parallel fuzzing we were really proud of, but broke it last week. So I pulled that code out, and right now you can only add one target, although you'll see you have the capability to add many. So I just pulled the splitting algorithm out because we had broken that. Another really cool thing we have is sequence honing. So for any of you who have fuzzed before, I don't know how often this has happened where, let's say we have test case number 100, it generates a fault. We go back to replay 100 and we get nothing. So, it's not like the world has changed. It's because there's probably some subset of sequences beforehand that set up that vulnerable environment for 100 to come in and do its dirty. I gotta kill this thing. Hold on 1 second. Oh no. There we go. So what we can do is because we have all these components built in, we can write a really easy script to kind of hone down what is that set of test cases. So here's the first, whatever, quote-unquote, algorithm I came up with to do it. I start from the last test case that caused a crash, and I start stepping backwards. So send 100, doesn't cause a crash, cool. Send 99, 100, no crash, 98, 99, 100. And you keep doing this until you find the final window. So maybe sending from 40 to 100 is what's going to cause a crash. So we know that somehow 40 is involved and 100 is involved at this point. Then we start eliminating sequential bundles from this range. And the bundle size is a ratio of the window size. So, in this case we have a range of 60. Maybe it'll start eliminating 2 at a time. And it'll resend the whole sequence with those eliminated, check for a crash. If there is still a crash, it'll start eliminating more and more. And so in the end, you're going to end up with the final exact sequence. Like if you send 40, 45, 95, 99, and 100, it's going to trigger this crash. And this can take a long-ass time, like a long-ass time. But it's way, way easier than manually doing it on your own. And you have time, and it's all automated. You just set it up, and you come back a week later, and it should give you the exact, sequence. So we mentioned the parallel fuzzing. The heuristic feedback loop, this is the more advanced version of that IDA fuzz extender, which is really simplistic. So what we're going to do is we have code coverage. We're watching everything. We're single-stepping through. It would be nice if the current primitive that's being fuzzed has gone over an area of code that has an integer comparison, for example, and we're dealing with an integer. The feedback loop will send it back to the fuzzer and add it to the integer library for that specific primitive. And so there are way more scientific ways of doing this. Both Greg Hoagland and Halvar are working on what I call path math, where you can say, okay, if I'm here and I want to go here, how do I generate the inputs mathematically so I can force this execution? Neither one of them have finished it yet, but in talking to a friend at Microsoft, apparently they already have it, where their fuzzers are capable of fuzzing every single code flow. So I guess we don't have the coolest fuzzer on the block, but we have the coolest free fuzzer on the block. Code coverage monitor is done. Oh yes, we didn't bundle it because it adds a lot more requirements. So the installer would have to actually include PyMay, and I don't have a PyMay installer, but now I have an installer guy, so Aaron's going to be creating one for me.
Maybe.
Another idea we had is PCAP binning. The same way that we can bin crashes, we want to bin PCAP. So if you're fuzzing your router or you just don't have the option to put a debugger into it, it'd be nice if we can just look at those responses and categorize those as well. So a simple example, we're fuzzing a web server, 404 responses versus 202 responses. Or like if you're fuzzing the Xbox, for example, which we've done with Sully, you can do this PCAP binning. File fuzzing, although we've designed this really for network protocol fuzzing and the session is specific to that, the data generation is really global. So Peter Silverman's already written a beta replacement called file session. And also, alternatively, you can just do this data generation and loop through the .render call, and then take all these generated files and just plug it into Cody's file fuzz and use that as a testing harness. So you can do files with this as well.
It just returns the raw data, so you can do basically whatever the hell you want.
And the last thing I wanted to mention is that we may create a web GUI for like drag and drop blocks, put primitives on it, right-click, pull up the dialog box, set the options, all that crap. And then what would be really nice is if then we just made an appliance-based distribution. So it'll just be a VMware image. You download it, no install required. It's got a web interface. You connect to it, you design a request, save it to the library. Do another request, save it to the library. Create a new session, tie them together in an interactive graph, add some targets, and start fuzzing. And it's all doable because I see it in my head, I just don't see it motivationally to go out and do it. So it would make this a lot easier to use, but it's not going to make it any more powerful. So we just now hit the time limit. But are there any questions? Sure.
I was wondering how you said before you could bring in Wireshark XML package.
Mm-hmm.
Is that an exception to setting up a block-based deal? Or?
No, it's not. So the question was, what do we do with these PDML files, right? This PDML file, we just parse it, and instead of you having to copy-paste hex bytes, it's just going to save you some time, because it's going to say, here's a block, here's a string, and depending on how well Wireshark knows that protocol, it's going to do a little bit more, a little bit less work for you.
And even in unknown protocols, I built in a little bit of heuristics with it, so it'll kind of look for ASCII, and if it's ASCII, it'll define it as an S string rather than an S binary and stuff like that.
And that's getting smarter as we use it more. There were some other questions. Yep.
You guys have a provision for multi-tiered applications where I need to monitor multiple machines, multiple processes?
I haven't done that. That's actually really interesting where you're fuzzing one thing. The question was, do we have anything for multi-tiered applications? So if you've got two systems and you're fuzzing one and the other one breaks, it would be very doable. I mean, you can have multiple agents. It's just adding a new feedback loop, right? Where instead of checking one, you're checking both. But
we're working on an agent API that'll make it really easy for you to add another agent, so you can very easily do checks like that if you needed to.
But I mean, all the components are there, so it's just a matter of building the logic in. So that sequence owner, it took me, a day to come up with a good way of doing it, and 10 minutes to write it, because all the tools are there. There were some other questions. Yep.
So I was wondering whether you can actually, using your block staticity modeling, read data from targets and basically parse it using your blocks, but you can, for example, manually study.
So the question was, can you just read data, make it a block, and do man-in-the-middle fuzzing? It's a good idea, and it's something that we've tinkered with. Actually, Cody has written a proxy fuzzer, and it's a lot more simple than that. What it does is it just sits in the middle. Anytime it sees a string, it'll expand it, it'll remove it, it'll put some crap in there. Anytime it sees an integer, it'll do stuff with it like that. But that would require that we parse that would require some protocol informatics stuff, right? Where you've got this big blob, you've automatically broken it out into fields, and then you're fuzzing those fields. So, yeah, conceptually, it's cool. Have we done it? No. Will we do it one day? Maybe. It's interesting. Somebody else had a question in this general area? Yep.